Hi guys, Dr. Robert Barrington here with some more nutrition advice. Now, I wanted to do a quick video today on vitamin D terminology. This is something that I feel is quite important. There's a lot of terminology surrounding vitamin D, and I feel some of it is often quite confusing and it's not fully explained. So I'm going to do a very quick video. I'm just going to hit the high points and I'm going to explain the basic terminology surrounding vitamin D. Now I'm going to use my whiteboard, which is actually my wardrobe, and I'm going to scroll all over it. So please bear with me as I put my very unreadable writing all over it. As you can see here, there are two forms of vitamin D that we can get in our diet. We can take in ergocalciferol and we can take in cholecalciferol. Now, ergocalciferol is sometimes called vitamin D2 and cholecalciferol is sometimes called vitamin D3. Now, ergocalciferol is produced by plants, and therefore, if we want to take in ergocalciferol, we need to eat plants. Cholecalciferol is produced by animals, and therefore, when we eat animal flesh, if there's any vitamin D in that, for example, maybe in eggs as well, and animal flesh, meat, that would be cholecalciferol. Supplements tend to contain both forms. You can buy supplements with ergocalciferol in it, and you can buy supplements with cholecalciferol. Now, biologically, there are differences between the two molecules, and the consensus in the scientific literature is that the more biologically active form is vitamin D3, which is cholecalciferol. And that's not surprising because we produce cholecalciferol ourselves, and it's because it's the natural form that we produce ourselves. It's not surprising that it actually has more biological effects. Now, that's not to say that vitamin D2 is not useful. It still has the effect of vitamin D. It's just not quite as strong as vitamin D3. So if you take ergocalciferol in your supplements, if you do supplement with vitamin D, you'll need slightly more of it in order to be able to get the same effect. Now, these are the dietary forms of vitamin D that we have when we eat food, but both of these, and these are available in the diet. Okay. Now, if we go out into the sun, we can produce our own vitamin D through the action of ultraviolet B radiation on our skin, and that produces cholecalciferol because we are effectively animals. So when we go out into the sun, the vitamin D that we produce in our skin is cholecalciferol. But like I say, we can get ergocalciferol in the diet, but when we take these both in the diet, they both form a common pool with the vitamin D that we produce in our skin. Now, this is the form that we get in our diet, but these forms are not actually active. These are not the forms that have the biological effects in our bodies. What happens is they are hydroxylated. And they form something called 2,5-hydroxy vitamin D. So when we take in a dietary source of vitamin D, or we produce it in our skin, we hydroxylate the vitamin D to produce 2,5-hydroxy vitamin D, and that happens in the liver. Now, 2,5-hydroxy vitamin D is the biologically active form of vitamin D. It's what's measured when you measure your blood levels of vitamin D. So when you go and have a blood test and you're measuring your blood levels of vitamin D, you're not actually measuring vitamin D, which would be ergocalciferol or cholecalciferol. You're measuring your 2,5-hydroxy vitamin D content. Now, if you take in ergocalciferol from the diet, you produce 2,5-hydroxy vitamin D2. If you take in cholecalciferol, you produce 2,5-hydroxy vitamin D3. And obviously, the form of the vitamin that you produce in your skin is hydroxylated to D3 because we produce the cholecalciferol in our skin. So these are the biologically active forms. They're really generally referred to as 2,5-hydroxy vitamin D, although there are slight differences between how they're referred to when they're in the plasma. Now, This is the biologically active form, which has most of the cellular effects, but it can be further hydroxylated in the kidney, and that would produce 1,2,5 dihydroxy vitamin D. So that's another hydroxylation. So that produces another form of vitamin D that's 1,2,5 dihydroxy vitamin D. So we take it in the diet, or it's produced in the skin. It's hydroxylated to 2,5 hydroxy vitamin D. That's the biologically active form that is measured, and then it can be hydroxylated further to 1,2,5 dihydroxy vitamin D. Now this also has cellular effects, and this is one of the forms of vitamin D that will actually lock onto your DNA, and it will enter the cell membrane, it will enter the nuclear membrane, and it will actually bind directly to the DNA in your cells, and it will cause cellular effects. What are the effects of vitamin D? Originally, vitamin D was seen as a substance that was able to prevent the deficiency diseases, rickets and osteomalacia. They're calcium-related disorders that are related to the bone, the softening of the bone. Osteomalacia was a softening of the bone in adults, and rickets is a softening of the bone in children. Vitamin D was thought of, that was the only role that vitamin D was seen to play. It's now known that vitamin D plays a much larger role in our health, and vitamin D is required for our immunity, and it's required for cell regulation. And some of the diseases now that are seen as being associated with low levels of vitamin D include obesity, metabolic syndrome, cardiovascular disease, cancer, also multiple sclerosis and diabetes. So there's lots of diseases that are now being associated with vitamin D, but most importantly, vitamin D is needed for our immune system, and low levels of vitamin D are seen as being detrimental to our immunity, which is possibly the main reason that we tend to get upper respiratory tract infections during the winter when we don't have access to strong sunlight. And this has led a lot of research on the path of wondering how effective dietary supplements of vitamin D would be. And this is where we come to all of this information that is now becoming quite mainstream. Supplements do seem to have an effect in terms of raising our plasma levels of 2,5 hydroxy vitamin D. And the question is, what should our plasma levels be? Now, there are two ways of measuring, there are two units to measure plasma levels. And when I refer to plasma, what I'm referring to is a part of the blood. They're referred to as plasma levels, but really we're talking about blood levels. So there are two ways of measuring vitamin D. We have nanomoles per litre, and we have nanograms per milliliter. Those are the two units that are used to measure 2,5 hydroxy vitamin D in our blood, and it's very easy to convert from one to the other. If we have 100 nanomoles of 2,5 hydroxy vitamin D, we have 40 nanograms per mil. So in order to be able to go from nanomoles per litre down to nanograms per mil, you just divide by 2.5. Now, nutritional papers tend to use nanomoles per litre, and it tends to be that you come across on websites both forms, and that's never really explained the difference. There are conversion charts, and I will put a link to a conversion chart in the comments box below this video, so you can interconvert your units. But if you have nanomoles per litre, if you divide by 2.5, you get roughly the nanograms per mil amount equivalent. So 100 nanomoles per litre is equal to 40 nanograms per mil, so it's quite easy to interconvert. In terms of vitamin D, what should your plasma levels be? What should your blood levels of 2,5 hydroxy vitamin D be? Well, this is a contentious issue. It's not fully understood, but it's suspected that around about 100 nanomoles per litre is the amount that you need to be able to keep your optimal immunity. Now, how much dietary vitamin D would you be required in the absence of sunlight to be able to get 100 nanomoles per litre? Again, this is a very difficult question to answer, but there is an estimate that has been given, and studies have obviously looked at this. And I will put a link to a paper that has much of this information in it in the comments box below this video. And the estimate would be that to get 100 nanomoles per litre as your blood levels of vitamin D, you would probably need to consume 4,000 IU of vitamin D per day. Now that's much higher than many people recommend. The recommended intake of vitamin D in the UK and the US, I think, is 200 IU. So it's much, much higher than the recommended amount of the vitamin that the health authorities recommend you have. Many people recommend 2000 IU, and even that might be too low. Vitamin D does have toxicity. At what point do you start to reach toxicity? Well, there are estimates that a blood level of about 140 nanomoles per litre is probably where toxicity starts to become possible. And it's thought that a daily intake of about 10,000 IU might be required to get plasma levels of your vitamin D up to 140 nanomoles per litre. So this is a very contentious issue, and I'm not making recommendations. I'm just talking about the research that's been done to date. 2000 IU is quite often what you see recommended on websites and even in research. And it's possible that to be able to get that 100 nanomoles per litre level, you may need up to 4000 IU in the absence of sunlight. Now, how much vitamin D, how much 2,5-hydroxy vitamin D can you produce if you have access to the sun? Now, somebody asked me this question in one of the comments, in a comment to a video just the other day, and they said they had access to the sun in the United States. I think it was in Arizona, which is obviously going to be a very warm part of the United States. And I think the estimates are that people have looked at this, and people who have access to very good sunlight and they spend a lot of their time in the sun, they can actually have plasma levels of 2,5-hydroxyvitamin D up to about 200 nanomoles per litre. I think the highest recorded individual plasma level of 2,5-hydroxyvitamin D was a farmer from Puerto Rico, and he had 225 nanomoles per litre as his plasma level of vitamin D, and that was just from the sun. So that would indicate for him that that's his normal biological level. So there is probably a large variety of the plasma level that you can maintain based on the sunlight exposure, and that would therefore reflect the amount of supplements that you would need to take to be able to get those plasma levels. Getting this sort of level in the diet is not really possible. Dietary sources of vitamin D are quite limited, and those sources don't tend to be rich enough to be able to give very high plasma levels. So obtaining these types of levels, the levels that are seen to be protective of your immunity, really requires either sunlight or supplements. There is a caveat to that, because it's starting to be realized that actually some foods do contain 2,5-hydroxyvitamin D rather than the original forms of the vitamin. And if that's the case, if this has been overlooked, it might be that those foods do actually provide are able to provide a higher plasma level of 2,5-hydroxyvitamin D than just by taking in the vitamin D alone. But that is still very early research, and it's not fully understood. But certainly some foods do have preformed 2,5-hydroxyvitamin D, which is what you'd expect, because we're able in our tissues to produce 2,5-hydroxyvitamin D. So it would be assumed that animals can do the same, and when we eat the animal flesh, we were eating some of that 2,5-hydroxyvitamin D. The problem is we just don't know how much 2,5-hydroxyvitamin D that is in the animal flesh, and it's not really been fully measured. This is something that may be researched in the next couple of years, and there might be a clearer picture of this. But those are the sort of levels that we're talking about. If I had to give a recommendation on supplements, I would always say go for vitamin D3, because then that's most of the research has been done on vitamin D3, and it stops you having to do a calculation as to how much vitamin D2 you would require. I would always recommend that you try and get as much vitamin D as you can from the sunlight. Now, the reason for that is it's possible to take in too much vitamin D through your diet, which can lead to problems with your calcium homeostasis, but your inbuilt ability to synthesize vitamin D has a natural cutoff. In other words, if you go out in the sun, your body will make as much vitamin D, make as much 2,5-hydroxy vitamin D as it requires, but no more. So you can't get a toxicity from going into the sunlight. You can, however, get a toxicity from taking in too much in your diet. So it's much safer to get your vitamin D from the sunlight. And if you have access to the sun, if you are from, a nice warm part near the equator and you have access to the sun all year round, I would recommend that you get your vitamin D from the sun. If you're in higher latitudes, perhaps you're in the United Kingdom or Canada or somewhere like that, and you only have access to the sun maybe for 6 months of the year, the other 6 months I would recommend that you possibly look at taking a dietary supplement. But there's no need to take supplements when you have access to the sun. So in the summer months in the United Kingdom, I don't take a supplement because I try and get my vitamin D naturally from the sun, and that actually is a very quite a safe way of actually preventing toxicity, because the vitamin D supplements you take during the winter don't have long enough to build up to a toxic level before you stop taking them, and then you allow the sunlight to be your vitamin D production method. One last thing to say is what happens to vitamin D in the body after we've got to the 1,2,5-hydroxy vitamin D. Well, this is further hydroxylated, and then it becomes inactivated. Eventually, hydroxylation proceeds, and eventually the hydroxylation steps inactivate the vitamin D, and it's excreted. Now, one of the reasons that ergocalciferol may be less biologically active than cholecalciferol is because the hydroxylation required to inactivate it there are fewer steps in that hydroxylation, so it may be excreted more quickly than the cholecalciferol. There's another reason that cholecalciferol is more biologically active. The 2,5-hydroxy vitamin D3 form of cholecalciferol, it binds more tightly to some of the transport proteins in the blood, and therefore it stays in the blood for longer. The ergocalciferol may not bind quite so tightly because it's a different structure, and therefore it might fall into that excretion pathway more quickly, and therefore it may be excreted more quickly. So there are a number of reasons why it's known that cholecalciferol is a better form of the vitamin, and therefore it's the form that I would always recommend in a supplement. But if you don't have access to it, you can simply do a small calculation to increase the amount of ergocalciferol. I would say that ergocalciferol is probably about 75%, maybe 80% as effective as cholecalciferol. So you can do a quick calculation to work out how much extra you would need based on the amount of vitamin D3 that you have in your diet. So there's a brief overview of vitamin D terminology. That should be most of the terminology you need to be able to go away and do your own research. I hope you found that interesting. As always, eat well, stay healthy, and protect yourself, and I will see you soon for another video. Take care.